Hey all, so today we're looking at the inverse of sine, cosine, tangent functions. So for it to be an inverse, you need to have a one-to-one function, and so that's why coming down to the sine function here, I'm not going to make you remember these graphs, but this is just why. So we have our original sine graph here, and then to make it a one-to-one function, I restrict my domain and range to this graph right here. So now it's a one-to-one, and I can make it an inverse. So that's where you switch your x and y values. So that's what I did in the last graph. And what's important out of doing this with the graphs is knowing our domain and range, so our restrictions. So the domain of the sine inverse function can only be from -1 to 1. And the range can be from negative pi over 2 to pi over 2. So, and then we're going to be looking at, given an equation, find the inverse function. And we'll go back to like how we did in the first semester of replacing f of x with y, swapping your x and y values, solve for y, and then replace y with f of x. So let's do some examples. So the first one is find the exact value of sine inverse -1. And another way to think of this when it's asking sine inverse of 1 is at what angle does sine equal 1? So I'm going to write, or what angle does sine equal 1? So if we solved, it would be theta equals sine inverse of 1. So at what angle does sine equal 1? And we're looking between that restriction of negative pi over 2 and pi over 2, which if we're looking at our unit circle, here's pi over 2, and here's negative pi over 2. So we would want to include angles like pi over 6, pi over 4, negative pi over 3. Pi over 3, not negative pi over 3. Right there. And then negative pi over 6, negative pi over 4, negative pi over 3. So these are just examples from our unit circle of ones we can use, but anything from pi over 2 to negative pi over 2 we can use. So that is sine equals 1 at pi over 2. So theta equals pi over 2. All right, find the exact value of when sine inverse -1/2. So when does sine equal -1/2? So at what angle does sine equal -1/2? So if we go to our unit circle, we find that sine equals -1/2 at 11 pi over 6. But 11 pi over 6 goes outside of our restriction because we need only up to pi over 2 and down to negative pi over 2. But we can match 11 pi over 6 is the same as that negative pi over 6. So theta equals negative pi over 6. Okay? So next we're going to use our calculator to find the sine inverse of 1/3. So we're going to go to our calculator, and we only do this if it's specifically asking us to use our calculator. So I'm going to go to our calculator. Oops, that's not the calculator. And what you want your calculator to be in is in radians. So I'm going to make sure that that's what I'm in. And then I'm going to do sine inverse. And here I'm going to press shift sine, and it comes up as a sine. If this is on the HP prime, if you have more of the like TI-84, you press still that shift button and it's sine, and it comes up with sine to the -1. But you never want to actually enter sine to the -1 power. You always want to do the shift sine. They're different. So sine inverse of 1/3, 3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1 Next, we have the sine inverse of 1/4. So I'm going to go back, shift, sine 1/4, enter, and that's 0.25. Okay, and then here's those restrictions we just talked about a little bit. All right, so let's keep going. So sine inverse of sine. So here we know that the sine inverse in sine just equals what x is. So whatever that angle is, it just equals x. But it has to be within this restriction here. So when sine inverse is on the outside, regular sine is on the inside. It has to be from -pi/2 to pi/2. When sine is on the outside, sine inverse is on the inside. It has to be between -1 and 1. So this first one, we have sine inverse on the outside, sine on the inside. So it's that first one of being between -pi/2 and pi/2. So is pi/8 between that? Yes. So it is just that x value. Okay. Next we have sine inverse of 5pi/8. And we're going to ask ourselves, is that between the -pi/2 and pi/2? We're going to say no. But angles on our unit circle have reference angles. So we need to find our reference angle that has that same value as 5pi/8. Since 5pi/8 is not in our restriction of between -pi/2 and pi/2. So if we find the reference angle, we're going to do 8pi/8 minus 5pi/8, and we get 3pi/8. And now that's between our -pi/2 and pi/2, so that's our answer. All right, next we have sine inverse is 0.8, so now we're using that second one of wanting to make sure we're between -1 and 1. Is 0.8 between that? Yes, so our answer is 0.8. Now looking at sine inverse of 1.8, that's larger than 1. And it's not like our angle, how we can do a reference angle that has the same value. Nothing else has the same value of the number 1.8. So this is undefined since it's outside that restriction. Okay, here's those graphs to explain our different ranges for cosine and tangent inverse. Again, I won't make you memorize these graphs. They're just here to help explain. So cosine now is for our angles 0 to pi. And tangent is like sine, where it's from pi/2 to -pi/2. Cosine's 0 to pi. Okay, so this first one is find the exact value of cosine inverse of -√2/2. So we're going to ask ourselves, look at the unit circle from 0 to pi, and for what angle does cosine equal -√2/2? Cosine is negative in our second quadrant, and the x value of √2/2 is at 3pi/4. So theta equals 3pi/4. The tan inverse of -√3, we look, that's in quadrant 4 at 5pi/3. That's outside our restriction. We need from pi/2 to -pi/2. And 5pi/3 has the same value as -pi/3. So that's what theta equals here. Okay. Here we're finding the inverse of this function. So we're going to go through our steps. So first step, switch f of x to y. So y equals 2 sine x minus 1. Then we're going to solve for y. So start solving for, second step, switch our x and y value to sine y minus 1. Now step 3, solve for y. So first I'm going to add the 1 to both sides. X plus 1 equals 2 sine y. I'm going to divide by 2. So x plus 1 divided by 2 equals sine y. And I need y alone. So when I what can I multiply sine by to get y alone? And that's sine inverse. Sine times sine inverse, they like cancel each other. So sine inverse of x plus 1 divided by 2 equals y. And last step, switch y back to f of x. So f of x equals sine inverse x plus 1 divided by 2. Okay. Next, solve the equation 3 sine inverse x equals pi. So the first thing I'm going to do here is divide by 3. So I have sine inverse x equals pi over 3. Here I'm going to, if I want to solve for x, multiply both sides by sine, because then that gets rid of that sine inverse. So sine pi over 3. So x equals root 3 over 2. Looking at our unit circle, that's the value we get. All right, let me know if you have any questions. That's it.